lecture we will discuss about a regular language and regular expression. Till date we have seen the formal languages and how to convert those languages into grammar and grammar to respective automata and vice versa. That means an DFA or NFA is given, and from that DFA and NFA how to convert it to language or grammar, vice versa. Now what is regular language? Now whatever be the language that you have seen, suppose I am giving you one example, LG NVN n greater than equal to 0. This is a kind of a language, and we can convert the grammar of this particular language also. Now if a language is represented using 3 parameters, that is union, concatenation and clean star, then the language is called regular language. Now what is union, what is concatenation, and what is clean star? Union, which is symbolized by this symbol, concatenation that is a dot, and clean star that is a star itself. So if I can represent a language either using union or concatenation or a clean star, then that language will be called a regular language. Now let us see from an example, then it will be much more clear. Now suppose if a language I am giving that example, that LG equal to A and B, where n greater than equal to 0. That means n number of A will come, that is followed by a B. Now can I represent this language using either union, that is U or dot or star? Dot means the concatenation, so yes, I can represent it. I just write an. How to represent this an? That case I have to show that what is A star. A star means this one is clean star, basically this one is clean star. Clean star means that A may appear lambda number of times, that means no A can appear, a single A can appear, or multiple number of 2A can appear, or 3A can appear, or 4A can appear, or up to dot infinite number of A can appear. And dot means that A dot B, that means A which is followed by a B, that is represented by this A dot B. And A union B means that A, either one occurrence of A will come or one occurrence of B will come. So if I can represent any language in this form, either union or concatenation or clean star, then it will be called a regular language. Now for this A and B, how to represent using either union or concatenation or clean star? So an means n number of A, that means the lowest value of A is 0 and the upper value of A may be infinite. So can I represent this A as A star, and after that B, and in between them there is the dot. So this is the representation of A and B in the form of these 3 parameters, either union or dot or star. So I can say that this language is a regular language. I think it is clear. Now what is regular expression then? Similarly, like the regular language, if a language is represented using plus, dot or clean star, then it is called regular expression. That means whatever the regular language I have told, if I can represent using this either plus or dot or star, then it is called regular expression. Here plus is the is actually union. That means either one occurrence of A or one occurrence of B must appear. Means right now if I represent this one, that is A star, that is clear, that is the clean star. If I represent it as A dot B, that means A followed by B. Now if I represent A dot B whole star, what does it means? That means lambda occurrence of AB, or one occurrence of AB, or two occurrence of AB, one AB followed by another AB, in between them there is a dot, or AB dot AB dot AB, that is multiple occurrence of AB. So that is represented by AB star. Or suppose if I write A plus B, what does it mean? It's an union, not a algebraic plus or arithmetic plus. Means that either one occurrence of A will appear or one occurrence of B will appear. That is the meaning of A plus B. Now what is A plus B whole star? It means that either lambda occurrence of A plus B, or one occurrence of A plus B, or two occurrence of A plus B, or multiple occurrence of A plus B. Any number of. So now from this A plus B, either I can take A or B, from this A plus B either I can take A or B, or from this A plus B either I can take A or B. So in this way I can form the entire A plus B whole star. Now I hope it is little bit clear. Now there are some properties of regular expression is there. The properties of regular expression is if R1 is a regular expression and R2, R3, R4, R5 are regular expression, then R1 plus R2 plus R3 up to dot dot Rn is also a regular expression. Similarly, if R1, R2, R3 up to dot dot Rn is regular expression, then R1 dot R2 dot R3 up to dot dot Rn is also regular expression. And if R1 is regular expression, then R1 star, that is the clean star, is also regular expression. Now in brief, if I want to say that if R1, R2, R3 are regular expression, then union is also a regular expression, concatenation is also a regular expression, and clean star is also a regular expression. As well as we have seen that how regular language which can be represented using that is the union, concatenation, and clean star. Now are the all languages that we have seen earlier are regular expression? The answer is simply no. All languages cannot be converted using this three parameter, that is union, concatenation, and clean star. Suppose if I give an example of this one, LG equal to A and B, and that we have shown to you earlier, n greater than equal to 0. Now can I convert this language into a regular expression? Well, most of the students that they make the mistake is that they convert it as an A star, B star. A star means any number of A that can occur, or no A may occur, and B star is any number of B may occur or no B may occur. But that does not guarantees that the same amount of A and same amount of B will appear. The number of A over here and the number of B may be different. So A star B star can never be a regular expression of A and Bn. A star B star is the regular expression of An Bm, where n greater than equal to 0 and m greater than equal to 0, means that whatever be the number of A and whatever be the number of B, they are not related to each other. Now the main problem of regular expression is that it doesn't have a memory. That means it cannot memorize that how many number of previous alphabet has appeared, the same number of alphabet, the next alphabet has to appear at the same number of time. So these types of memory is not there, so I cannot convert it to a regular expression. So this one is not a regular expression, or regular language, but this one is a regular expression as it doesn't contain any memory. So if I cannot form a regular expression, that means I cannot construct a DFA also. So for this one, DFA is not possible. DFA or NFA is not possible. That means finite automata is not possible at all. But for this problem, I can construct a DFA. DFA is possible. You can take it as an exercise and try that whether I can draw a DFA out of this A and B n or not. If I can form, obviously it will be a regular expression. And there is another method, formal method, to prove that a language is a regular language or not. That is the pumping lemma. Through this we can prove it, but in informal way you can straight away say that a language is regular or not by constructing its DFA. Right. Now we will show you some more examples that whether it's a language is a regular expression or not. So the first problem is that all strings that is ending with 0 1, that means the strings can start with any combination 0 1 or 1 0 1 1 or 0 0, that doesn't matter, but it must end up with 0 1 in all cases. So the first two strings may be anything, alphabet may be anything, but the last two must be combination of 0 1. So how to confirm that the first two strings may be any string? So that is simply by writing 0 plus 1 whole star, and after that it will be end up with 0 1. So that is the answer. Now next one is all string, that is a combination of A, B or C, but it must consist of exactly one A. But for the B and C there is no restriction specified. B or C may be any number. Now how to confirm that exactly 1a will be there. So as a is the only string that must have to be present, so we will write it straight away. Now before a there may be any combination of b and c, but a will not be there because the number of a the desired number of a is already we have reached, and after a there may be any number of b and c. So how to confirm that the number of b and c, any number that may appear before a, by straight away writing b plus c whole star. And similarly, how to confirm that any number of b and c, by simply writing b plus c whole star, and in between them a is there. So this is the answer. Now for the third one, all string that any combination of a, b, c with at least 3a, that means the condition for a is mentioned but the condition for b and c is not mentioned. So at least 3a must be there, and in between them there may be any number of a, any number of b, and any number of c. So as at least 3a must be there, so we must write a straight away, a. Now why I have written this 3a far apart, because this 3a may appear at any positions. It is not like that 3a will appear consecutively. In between this 3a there may be any combination of a, b or c may be possible. So how to ensure that in between this 2a there may be any combination of a, b, c? Just writing a plus b plus c whole star. That means that any number of a, any number of b, and any number of c, or in with any combination can come. And in between this 2a also I can write that a plus b plus c whole star, and after this a I can write it as a plus b plus c whole star, and before this a plus b plus c whole star. So this guarantees that the at least 3a will come. Now let us consider some more problem. Now in this fourth problem, it is told that all string with no more than 3a, that means there cannot be more than 3a will be allowed, but 2a will be allowed, or one single a will be allowed, or no a may be allowed. Now if first start with no a, if there is no a, that case any number of b may come, a, b plus c whole star. Next, one a may be there. If one a is there, that a may appear before b or c, or in between b or c combination, or after b or c combination. So how to confirm this one? Just writing b plus c whole star before a, and writing b plus c whole star after a. Now how to confirm that 2a, because it is written more than no more than 3a, that means no a will be allowed, 1a will be allowed, or 2a will be allowed. If 2a, at least 2a is allowed, that means before that a I can write b plus c whole star, in between this 2a I can write b plus c whole star, and after that a I can write b plus c whole star. And so I can confirm that from this one no a is confirmed, from this one at least 1a is confirmed, and from this one at least 2a is confirmed. And if more than 3a is there, that will not be accepted by this regular expression. So this is the answer for this question, to find out the regular expression. So in this manner, so you have to keep the keep it in mind, the what is the jargon of words, what whether it is at least or exactly or no more than. So based on this you have to construct the regular expression. Next one, again minutely consider the jargon of words. All string with at least one occurrence of each symbol means that within your string at least one a must be there, one b must be there, one c must be there. Now this a, b, c may appear any combination, means that it is not like that one occurrence of a, b and c means that it will be in the form of abc, or maybe in the form of a bca, or maybe in the form of a cba. So first one, let us consider that if it is in the form of an abc, or it may be in the form of a BAC, or it may be in the form of a CAB, or it may be in the form of an ACB, or maybe in the form of a BCA, or maybe in the form of a CBA. So any combination is possible because it is told that at least one occurrence of each symbol must appear. Now what about the when suppose if I consider the first one only, a, b, c. Now in between the a, b, c there may be any combinations of a or b or c may comes, yes or no? Yes. So if we consider the any combination of a, b, c in between this a, b and c, so how to confirm that any combination of a, b, c? Just writing that a plus b plus c whole star, it confirms that any combination of a, any combination of b, or any combination of c may come, right? Now to if I write a plus b plus c in between a, b and c, then the string size may become bigger. So instead of this I am converting it to an x. So write x in between a, in between bc, after abc or before abc. Similarly write this x in between b and a, in between a and c, after bac and before bac. Write this x here also, ca and ab in between, after cab and before cab, in between ac and cb, after acb, before acb, in between bc, in between ca, after bca, before bca, in between cb, in between ba, after cba and before cba. So any combination of a, b, c is being confirmed. Now the third one, you can consider any combinations of the string, but it must start with an a and end up with another a. So this is the simplest one, and in between the ab, in between the a and a, starting with a and ending with a, there may be any combination of a and b. So how to confirm the any combination of a and b? Just writing a plus b whole star, and before that just write an a, and after that write an a. Now let us solve more problem. So the first problem is a b square omega b to the power 4, means that in between omega means any combination of a b. Before omega there may be a b square, and after omega there may be b to the power 4. So this problem is similar kind of problem number 6. So it is the answer should be just a plus b whole star. Before that there will be a b square, and after that there will be b4, nothing else. And the next one, for this one we have already designed the regular language also, and also the grammar also, even DFA also, DFA also, but language we have not designed. But we can easily, as the DFA is constructed, so we can easily form the regular expression also. So what does it say is that the omega may consist of any combination of a or b, but mod omega is the length of omega. Suppose if I consider omega equal to a b, then mod of omega equal to 2. If omega equal to a b a, then mod of omega equal to 3. So what is the mod of omega? Just make a modulo 3 division. Then what is the remainder I am getting in modulo 3? In this case I should get 2, in this case I should get 3, mod 3, it's a mod 3. So in this case I should get 0. So what b may be the mod omega value? If you make a mod 3 division, then you should get the value should be equal to 0. So when we will get the value should be equal to 0? If it is an integral multiple of 3. So if the value is the length is 0, that case mod omega mod 3 will be 0. If the length is 3, the mod omega mod 3 will be 0. If the length is 6, the mod omega mod 3 will be 0. So in this way we will get the different string. Now how to confirm that? So as we found out that the length of the, it may be any combination of a and b. So any combination of a and b will be represented by how? It may be represented by a plus b whole star, right? Now any combination of a plus b, but the length must be 3 or integral multiple of 3. So how to confirm that the length must be integral multiple of 3? Just writing a plus b dot a plus b dot a plus b. Now from that a plus b I can get either a or b, any one of them. From that a plus b I may get either a or b. From that a plus b either I may get a or b. So in this case, from this expression I am getting a alphabet of length 1. In this case I am getting an alphabet of length 1. In this case I am getting an alphabet of length 1. So total length is 3. So if you make a modulo 3 division, then I must get the value 0. So this must appear any number of times, which can be represented by star only, or I can write it as a plus b whole cube star, same thing. Now let us see the next problem. Any combination of 0 1, that means the digits, but the 9th digit from the LSB must be 1. LSB means if a digit I write 0 1 0 0 1 0 1 1 0 0 1 0 like this. How many digits? Let us check. 1 2 3 4 5 6 7 8 9 10 11 12 13 14. So this one is my LSB position and this one is my MSB position, right? Now from the LSB position, let us count that what is my 9th digit, and in between the digits it may be any number, either it may be 0 or it may be 1. So 1 2 3 4 5 6 7 8 9. So 9th digit must be 1, and before 9th digit the rest of the 8 digits may be any combination of 0 and 1, and after 9th digit there may be any combination of 0 or 1. So how to assure that? So it is also very simple. So from that problem statement I can easily identify that the first digit may be any combination of a or b, second digit may be any combination of a or b, third digit may be any combination of a or b, fourth digit may be any combination of a or b, fifth digit any combination of a and b, sixth any combination of a and b, seventh any combination of a and b, eighth 1 2 3 4 5 6 7 8 maybe any combination of a and b, next one is 1, and the last digit after that it may be any combination of a and b. So this is my 9th digit, right? So 9th digit is confirmed as 1, and rest of the digits are any combination. So even it can be written in a simple manner, that is 0 plus 1 whole to the power 8, then 1, and after that 0 plus 1 whole star. And Bm n greater than 3, m less than equal to 3. So, how to confirm this one? And the number of n, the minimum value is 3, and after that any number of values may be possible. So, it can be shown that either A3 A star, and after that a combination of A may be anything, or it can be written as A2 A plus. A plus means that it does not contain any lambda, at least one A must come from here and rest of the 2 A's are there. So, for simplicity I am writing it as A3 A star. Okay. Now, for Bm, that is the minimum maximum value of B, maximum value of B must be 3, but more than 3 is not possible. So, 2B can be possible, 1B can be possible, even no B can also be possible. So, how to confirm that? So, no B can be confirmed by only lambda, 1B can be confirmed by single B, 2B, and even 3B can also be possible. So, this one is confirming this statement, this condition, and this one is confirming this condition. So, in this way we can come out with more and more problems, but one thing we have to keep it in mind, that if we can construct a DFA from a language, then that language is called regular language or regular expression, otherwise it is not a regular.